All right, so let's continue from where we left off. All right, so like I said, we will not talk about geocoding methods. That's why you have to be in a lecture. Sorry, but like I said, I need to update this one. I'm not punishing anybody who is not part of the class, but of course, sometimes it happens. We'll talk about network analysis. So transportation, because every civil engineer needs to appreciate it. So GIS application to this one. So transportation, network analysis, we'll touch on that. And so what we want to study under this one is some analysis that we can do on a network. What is a network in the first place? How does GIS implement networks? Are you okay? Hey, I haven't actually admitted on it. All right. So I have to repeat myself. Let's wait for these guys. Okay, so as I said, we won't be talking about geocoding methods and data management. We won't be talking about that. Take note of it. It's a lecture. Take a piece of paper and write things down. Take note of everything that's being said. Be proactive. I know you are busy, okay, but it's very important. Anyway, how far are we going with this lecture? We're supposed to start at 1:35. Time is 3:15. How far are we going? Class rep, are you there? Can you hear me? How far can we go? What time can we close? You have another lecture, let me know. Anybody can you all hear me?
You said today introduction. Is that not so?
No, but I want to know, normally I do 2 hours. I'm done. So when can we stop? Because sometimes I can go on and on. So
you say you normally do 2 hours. So
yeah, so when we have done 2 hours, how many minutes have we done?
We started.
We started at what time?
One something.
We started 1 something and it's now 3.
So we are close to the 2 hours.
So we are close to it, right? Okay. Wait. So let me just talk about one more thing. We'll just end it here. Is that okay? All right.
All right.
Wait. So I'll ask for a few questions. That will make it even nicer. Like I said, this lecture is very important to me because it's the beginning, and you don't have to struggle with the beginning. Okay. I talk about everything in this lecture. Network analysis, we look at, for example, the shortest path algorithm, which is also called the Dijkstra's algorithm. It's what allows you to get the Uber driver to find where you are. It finds the shortest path on the network. Are you getting that? So we're going to learn how that works. Maybe you can implement it and make an app for it and then make some money. Okay. You never know. We all like money. Okay. But anyway, I wish you luck in your pursuits of, app development. All right, so network analysis, we look at that. I would like to talk about 3D surface renderings. 3D surface renderings. So what do I mean by that? We're talking about view shed analysis. It's very good to understand this one. I'll give you an assignment of watershed analysis. You just the same concepts. Are you okay? We will learn about what the surface is. What is a surface? Are you okay? And then what kind of operations can be applied to a surface? And we look at multi-criteria analysis. Okay, so here you want to make a selection for a site. What's the best place to site a landfill? Are you okay? A landfill site. So nice question, isn't it? The question is where. should go and put it behind Wager Township? Should we put a Budumram down in the central region? Where's the best place to put it? You know, like, so we will have to understand the concept of surfaces. Then we add on network analysis. I think these two will just be fine for you. And then you are good to go. Are you okay? All right, so this is the outline of what I intend to touch on. Like I said, I'm not going to be talking about geocoding methods. I'm not going to be talking about data management and display. Okay, so take note of that. Okay, all right. And then basically that is that. So I'm going to just touch on one thing, and then we just be out of here. One thing. Wait, any question on so far what I've said? Any question? Is there questions that are important? Please ignore this one, ignore the percentages. It's nothing like that. Any question for me?
Yes, sir.
You have to ask
Hello,
questions. Yes, go ahead. Yes.
Yes. Sir, please, can the police service use the GIS to monitor the robbery activities in the country?
The police can, but the police are normally interested in crime incident location, and we will not be touching on that because that application will throw us a bit off in terms of security. Okay, not engineering. So remember that security is a field study, and then engineering is a field of study. I hope you are with me.
All right. Yes. All right.
But definitely they do. So if you're interested in that, you won't get that in the exam. You won't get anything on that in the exam. You won't find anything like that. But you have to learn outside this lecture. Is that okay?
All right.
Yes. But it's a very good question you've asked. You can see that GIS can be applied to so many areas. That is the bottom line. It can be applied to so many areas. All right. In fact, GIS can be applied in so many areas. So it has different definitions attached to it. Any more questions that, you know, if you have any question for me so far, I've been talking a lot. Do you have any question?
So, one more question.
Yes, ask me.
So GIS, its main objective is to locate where issues or problems are.
Okay, yes.
That apart from that, does it profess the solutions to the issues that is identified on it?
It's actually GIS is a decision support tool. So it does give you a solution, but the solution is not like, okay, you go and do it. It's supporting your decision. In other words, when it says that this is the best place to go and get something done, it guides you in your decision making. Are you with me?
Okay.
For example, GIS can say that, okay, the best place to dig gold is right at the Flagstaff house. Are you with me?
Okay.
So you know the Flagstaff house, right?
Yes.
So you see the solution is giving you is not correct, right?
Yeah.
You can't go and take that monument. It's monumental, that place. Is that right?
Yes.
So here you can see that GIS is only supporting you in making your decision. Because if you go rigidly by that, so if you were to install a GIS in a robot, and robots were ruling the world, if in that idealistic situation of view, if GIS were to be inbuilt and installed in a robot, and they were running the city, they will start digging up everywhere. Okay. Yes. Are you getting me? So that is how it is. GIS is actually good for just obtaining information and for collecting and storing information. When you look on the board, you can see that your question actually has the answer right here highlighted. A powerful set of tools for collecting, storing, retrieving at will, transforming and displaying special data from the real world. Okay. So yes, it will give you a solution, but you have to decide whether to use it or not. Are you with me? So it can help you to track and know.
Hello,
okay.
Sir.
Yes, go ahead. Yes.
Hello, sir.
Yeah.
So in the aspect of exploration,
yes.
The GIS, does it help in that direction also? For instance, like oil exploration, does it help?
Okay, are you talking about mineral exploration?
mineral, oil, those things.
Yes, it's very good. It's very
specifically, let's say oil exploration.
In fact, is GIS is very good in those areas. Excuse me, because you need to do so many analysis when it comes to the exploration industry. First, you have to drill. You have to drill, do what we call drill holes, locate them. Are you okay? And then store how, for example, the depth at that location. You need to also assign the results from that drill as samples should be taken to the lab. Are you okay? And then you ask the question. I hope you are listening. And then when the samples have gone to the lab, the result from the lab should now be associated with that location. Are you with me? Now, when that has been done, for example, we can do what we call interpolation and create a surface. That surface will tell us the amount of resource within the study region. Did you understand what I actually said? Do you think you really understood what I said? Can you repeat it for the class? I'm interested in you repeating it for the class. Did you get me, or I should repeat myself? Should I repeat myself?
Sir, if you can repeat it for me.
I can repeat myself. Okay. If, before they dig, whether for oil or for gold or for diamond, they need to take samples within the area. Generically, the geologists have a way of just looking at the terrain and just telling that there could be, depending on the nature, the rocks that he finds in the area. Are you with me? Now, so if once an area has been declared that there's a potential for resource, then we do the exploration, and it involves actually drilling at certain random areas, or you can do random sampling, or you can actually do regular, and you could stratify. There are different types of sampling, and then you can do some sort of interpolation, okay, and generate a surface that gives you an idea the amount of gold in the area or oil in the area. Are we on the same page? So you don't mind before you get to know that there's so much oil. You actually explore first and know that there's so much oil. Then you start again. Otherwise, you can't invest into it. Are we on the same page, all of us?
Yes, sir.
We are good. Please, if you don't get it, please see David. David will explain it to you. Yeah. Okay, but please, I'm very particular about this. The question you asked, I'm interested in questions like that. And you should also be interested in finding answers to questions like that. Those are the questions you always get from me. I'm saying it again. These are the type of questions you get from me. Very practical. You read it, you have to understand and know what to do. Okay. Any more on this? Because you see, what I have on the board is telling you that GIS has different definitions. That's because people see it as a toolbox. And inside that toolbox, we can find tools, things that can help me to collect spatial data. Spatial data, is different from, data on, let me just say, soil moisture content. Okay, it may not be okay. It becomes spatial when we want to know moisture content across a certain region or area. So spatial data is all about data that has a locational component. Please take a pen and be writing on these things I'm talking about down so that you can give the right answer. Spatial data from the real world. So data is extracted from the ground. Okay, you go down and you take GPS and then you collecting data on the ground. Okay, Texan's hand is up. Texan, please talk to us.
So if I get you right, yes. You are saying that the GIS system is like you have to feed it an information before
you feed it with data. You feed it with data.
Okay, you feed it with data before you can get some information from it.
Thank you.
So let's say if you want a place to mine oil,
Yes.
So you look at a certain location,
right.
You look at the types of rocks, the ecosystem over there, and then you feed it into the system. So
Yes.
if you see that if the system, then the system can give you certain locations where you have those features,
Based on the
which can
data that
be a
you have fed with to it.
giving it to,
Yes.
so that it can give you a possible location where oil could be, right?
Yes, it can probably give you the extent, which you
So
couldn't easily do. Are you okay? With your own naked eyes, you couldn't know.
okay.
Yes.
So meaning that our cell phones that has the the GPS falls under GIS, right?
Your cell phone itself is not the GIS. The GIS is a system which we are going to talk about. It has so many parts. So the parts of the GIS are software, hardware, data, methods, hierarchy, and then the people. Are you with me? So your phone is a hardware. Are you with me? Now your phone also has software called Google Maps. It also has a software called Uber. Remember, you've installed an app called Uber, haven't you? Or Yango, right? Or Yango. Very good. So now, when you combine that app called Yango or Uber, and then your phone itself, and then you add the data coming from the GPS to it. So you have hardware data, you have software. Are you okay? Then you yourself, and then the Uber driver, all of you make GIS.
Oh, okay.
You get it. If you get this one, this course, you are done. You understand everything I'm talking about. But we're going to just learn the basic principles that will allow, that makes it possible to do. For example, how was the driver able to find where we are? It used an algorithm and network analysis. So that is why we'll talk about a topic called network analysis in the coming weeks. Are you okay? Yeah.
Okay.
Yes.
Understood now.
Very good. Thank you very much for the question. I am really grateful. It's important. Some questions help the lecturer too. Yes, so that's a good one. So you can also have database definition. There are people who see GIS to be a database.
So, sir.
Yes, go ahead. Yes.
So the GIS, according to the example given, like the Uber and those things, meaning they work like they are using map. Is that so?
Your question has to be defined again, because I've just talked about Uber.
I'm talking. Yeah, and I'm saying that because if you look at the Uber, you see, it's like when they are
they use the map. Yes.
Yeah, like it's a map. Yes. Follow before they get to your place.
Let me tell you what is. Let me. I'll cut you short a bit. And let me say something. You realize that the Uber drivers, even when they pick you up, sometimes they don't use the map anymore. But what the software really did wasn't to help them to find you per se. What the software did was to find all the Uber drivers who are around you. So that is GIS. That's the first one. Then it finds the driver who is closest to you. That is another thing that GIS is a principle in GIS, finding the closest, something that's close to you, proximity. Then it finds who is willing to go. That is software. So there's an algorithm that's also doing if then else inside your app, your phone. So there's a program inside your phone. So your phone has an operating system. Are you with me? And then the app is running on top of it. Yeah, every phone has an operating system. If you don't know it, please go and read your IT introduction to IT again and look at operating systems. Phones have operating systems. We have Android, okay. Then we have iOS for Apple phones. And so your phone, as you're holding it, is a computer on its own. Remember that. That's why I can talk about that in this class. So your phone is not just a phone. Your phone is a computer with a phone, a phone application. Please put it to your head. So you are right. The way you are thinking is right. Now you need to, the Uber drivers are using the map, but then sometimes the Uber app has done more for the driver than just the map itself, because not all of them use the map. When they pick you, you just sit in the taxi, then they'll be asking you, should I turn left or right? And you ask yourself, don't you have the map? And you tell them maybe the map is a little bit delayed, which tells you that the app has done its job. But the job that the app did also is GIS, which is the proximity hierarchy. Proximity is the main thing. Who's the closest on the network? All right, are we good? Are you good?
So, sir, meaning the GIS also use other system to support itself.
No. GIS itself is a system. So remember that the S at the end of GIS is a system.
I know.
So no, because you're getting it wrong. GIS doesn't use other systems. It is the system.
Itself.
It is the system itself. So the GIS is making use of different parts. I just said that. Maybe you are not listening. It has hardware, software, people, methods. So take a pen and write them down. Take a pen and write them down.
Subset. So they are subset.
Why don't you wait for him to explain so that you can ask your further questions?
No, I'm the one asking questions, so I have to get.
Okay,
you are still talking.
No, I have to, because what I want.
I have to teach you what you. I have to teach you, you know, what you are supposed to know. Otherwise, you'll be thinking a certain way, which is wrong. GIS is not using other systems. GIS itself is a system. A system is made up of different parts. That is where you will get it wrong. When you start thinking it's going to borrow. No, it's not going to borrow. It makes use of these parts to make it work. We don't call them systems. It's not borrowing from a system. Well, you can also look at it that way. Yeah, I think in that case, yes, you can look at it that it's making use of global positioning system. So GIS makes use of other systems. I think that's why you are trying to say. In that case,
I'm trying to understand whether the GIS feed, like, is something that feed on other system, or the other system that feed on GIS. Because it's a system by its own.
Yes, a system can make use of systems. So it doesn't matter. It's a political thing. Are you okay? Whether the egg was there before the chicken or the chicken was there before the egg. All I know is I have a barbecue chicken on my table. Are you okay? At the end of the day, I have egg to eat, I have chicken. So, but then bottom line is that GIS is a system. But as to whether the system, which systems is inside the other, look at GIS and don't be looking at which one GIS is inside. But we are only talking about GIS at the moment as our main topic. So every other thing is under it. Are you on the same page? Are you on the same page?
Yes, sir.
Yes. So in this class, GIS is on top. Every other thing is inside. Okay. Right. So GIS, you see, there are people who see GIS as a database. So there's a definition for database here. Database system, which most of the systems are spatially indexed. So in databases, we have indices, or indexes. Yeah, I think I'm saying indexes. And you also do queries. So you see, GIS can be, you know, when I went to Google Earth, I could just type Ghana and then it switched straight to that place. You know, that is querying. I was querying the system. So that query is what, you know, this definition is looking at. Okay, you can also look at GIS as an, you know, from an organizational point of view. And then etc. So this is where we are all we've been talking about this. Okay. Hardware, software, data, people. These are the parts. So I think in our next lecture, we are going to take our time and look at the components of GIS and discuss as much as we can. Are you okay? So you can see straight away hardware. What is it? Hardware is your phone is there, it's part of it. Computer is part of it. Talk about the parts that we can touch, etc. And then we talk about software, which is the program that programmers. If you heard about computer programmers, yeah, people program a computer, yeah. We have the data, Data, there are companies that work in just data. They just collect data, that's it. Okay, that's all they do to make a living. So data is important. It's raw. Data is a raw fact, without which you can't have any system working for you. The people are those who are using it. Yeah, we have the experts who actually make the system work, and we have the users who don't have a clue how it works, but then they want, without them, in fact, the user, those who create are creating for, for nothing. Then we have the methods. Okay, there has to always be a method in an organization. Okay, that you want to use a GIS to implement. It has to be a method. So the business rules in an organization. So guys, I think this being the first lecture, if you don't have any question, in fact, you can ask as many questions as you can. Otherwise, I'll just say goodbye to you for now. But if you have a question, you can ask. And then we'll continue on that. Yes.
Sure.
Yes.
The full meaning of GIS, that is the GIS is an
were you here when I started a lecture, please? Were you here?
Yes, I was here.
Okay, so now, you know what it is. What is the full name?
Yes, Geographical Information System.
Okay.
So it means that the thing is focused on information.
The focus is on the system. That's why you can't leave. You can't say, I can't say I'm teaching you geography. No, I can't say I'm teaching you information. No, I can't say I'm teaching you a system. I'm teaching you a bunch of things. The parts I'm going to talk about in this lecture, my goal is to talk about the parts of the system, which you are looking at on the board right now. Are you on the same page? Are you on the same page? Components of the GIS. More or less, it's like I used to work with an electronics repair company. So I was an apprentice for some years back. And then the inside, when they opened the television sets, I'm talking about the one that uses the cathode ray tube, the etikopo in Ghana, we call it etikopo, not the flat TV, flat screen we are talking about today. So in that etikopo or cathode ray tube television, people are still using it, trust me. You will find components. So as an apprentice or as an engineer, you were supposed to go and remove the component which is not working, and then you buy a new one and put it in, and then the television will start working, or the radio will start working. So when you open up any system, you find components. And so in our GIS, the components are hardware, software, data, and people. So everything I talk about in this class will more or less revolve around the components. Except that, of course, we're talking about certain things that we do in GIS, principles and operations and things like that. Okay, so that is what GIS is. You can't break it apart. Geographical is an adjective, or geographic is an adjective. Information, now you're having some kind of adjectival now. I'm not teaching English here, but you can see that geographic information system or geographical information systems, you need to put all of them together as a compound noun and then take it as it is. You can't break it apart. It's a bit of geography information. That information should be about the geography, geographical information. So the system will give you that. Okay, that is what you are actually saying. You are saying that it will give us, geographical information. Yes, but then you cannot say the focus is on the information. It's on the geographic information. Okay, the focus is on getting geographic information. All right. Any more questions? If there are no more questions, then I believe we will have to call it a day, and I'll have to post an assignment on the Lemas. I have to get used to doing that. Yes. for you to do. Yes. I hope it's set up. I hope the lemmas has been set up for you. And also, I'm told I'm supposed to also do something on Google Classrooms. I haven't been set up for Google Classrooms, but okay, I think it'll be fine.